What's up everyone, today I'm going to show you some simple formulas to calculate the radius of an inscribed circle of a triangle. In order to use these formulas you need to know all the sides of the triangle and at least one of its angles. However, if one of the sides is missing or no angle is known, then we can use the laws of cosine and sine to determine the missing parts of the equation. What's great about these formulas is that they are easy to remember. All you have to do is just pick up an angle that is known. For instance, let's say that this angle A is known. The radius of the circle is going to be equal to sine of A times the sides that actually form A, so Y and Z, and divide all of that by the sum of all sides, x plus y plus z. Let's say that we know this angle here, C. The radius of the circle is equal to sine of C times y and x, which form C, and divide all of that by sum of all sides, x plus y plus z. The same strategy works if we know B. So the radius is going to be equal to x times z times sine of B, all of that divide by x plus y plus z. Now we are going to do some examples to show you that these formulas actually work. Okay, so I've got here a triangle. I measured its sides. This side here, side Z, is roughly 6.6 centimeters. Side Z is about 4.4 centimeters. And side Y, as you can see, is 5.9 centimeters. I also measured the angle between Y and Z, angle A, which is about 78 degrees. Now, if we measure the radius here, we see that it is exactly 1.5 centimeters. So if this formula works, we should get as a result a number that is pretty close to 1.5 centimeters. So let's go ahead and plug these values into this equation and see what we are going to get. So R is equal to Y times Z, 5.9 times 4.4 times the sine of A, which is 78 degrees, and divide all of that by 6.6 plus 4.4 plus 5.9. Let's put this into calculator. Okay, 5.9 times 4.4 times sine of 78, divide all of that by 6.6 plus 4.4 plus 5.9. And as you can see, it is exactly 1.5 centimeters. You see the second decimal value is 0, so this formula works. Let's do another example. Here I have another triangle. I know two of its sides. I know this side is about 10 centimeters and this side is about 13.4 centimeters. We also know two of its angles. I know this is 26 degrees and this is 44 degrees. Let's try to find the radius of the inscribed circle. As we have already mentioned, in order to find the radius, we need to know all of its sides of the triangle and at least one of its angles. Here we know two of its angles, and that's more than enough, but we are missing one side here, side A. So our first objective is to try to find the value of this side here. We can do that by using the law of sine. So let's go ahead and do that. A over sine of 26 is equal to 10 over sine of 44. Solving for A, we have 10 times sine of 26 is equal to over sine of 44. We have, let's see how much is that. 10 times sine of 26 over sine of 44. That is 6.3 centimeters. Now we have all the information needed to find the radius of the inscribed circle. Let's observe the triangle from this side here. The radius of the circle is going to be equal to r, this value here, which is 6.3 times 13.4 times the sine of this angle, and divide all of that by sum of all angles. So 6.3 plus 13.4 plus 10. Let's see how much is this. Times 13.4 times sine of 44. Divide all of that by 6.3 plus 13.4 plus 10. As you can see, this is almost 2 centimeters, so I will round the answer to 2. Now let's measure the radius here and see how much is that. As you can see, this is almost 2, so once again the formula works. Here is the final example. We are asked to find the radius of this circle here. We are given all the 3 sides of the triangle, but we don't know any of its angles. So our first objective here is to try to find one of the 3 angles. It doesn't matter which one you pick. Let's try to find this one here. I'll name it angle A. Using the cosine law, we have 4 squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 times cosine of A. Solving for cosine of A, we have cosine of A is equal to 4 squared, which is 16, minus 3 squared, which is 9, minus 5 squared, which is 25, and divide all of that by this, minus 3 times 2, which is 6, times 5, which is 30. So A is going to be arc cos of all of this. Let's see how much is that. Minus 9 minus 25 over minus 30. As you can see, A is 53 degrees. Now we know how much is this angle A. This is 53 degrees. Now we are going to use the formula to calculate the radius here, which is r 3 times 5 times sine of A, which is 53, and divide all of that by sum of all sides, 3 plus 5 plus 4. This is going to be equal to 3 times 5, 15, times sine of 53 over 3 plus 5 plus 4, which is 12. Let's see how much is this. Okay, 15 times sine of 53 over 12. As you can see, this is almost 1, so I will round r to 1 centimeter. Let's quickly measure the sides here to see if this is true. So the radius is almost 1, so this is correct. This is 3, this is 5, and this is 4. So now you have no doubt that this formula actually works. Now let's try to quickly prove this formula here. We are going to do that using the area of this triangle. We know the traditional formula of the area, which is x times the height h times 1 over 2. We can also find the area of this triangle if we add up these 3 small triangles. this one, and this one. So the area of this little triangle is going to be x times r times 1 over 2 plus, we are going to add this area now, which is z times r times 1 over 2 plus the area of this one, which is y times r times 1 over 2. Now we know that this height here, h, is equal to z times sine of b. So x times z times sine of b is equal to, we can factor out r over 2. Sorry, I forgot to add 1 over 2 here. So x plus y plus z. We can add 2 to both sides of the equation, and we are going to get x z sine of b is equal to r x plus y plus z. If we divide both sides of the equation by x plus y plus z, we are going to get the formula for the radius, which is r x z sine of b over x plus y plus z. So here we got the formula which we already know. If you found this video useful or if you enjoyed it, please consider liking it. Also, if you have any questions, feel free to let me know what you think in the comment section. Thank you for watching.